Okay, so we have this function. We're going to solve the equation x squared minus 5x plus 6, which matches this, equal to 0, using the quadratic formula. Now, when I laid that out to people that weren't here last time, not everybody knew how to use a quadratic formula. It's very simple, so I have to tell you one more thing. Formula gives you the solution to the equation ax squared plus bx plus c equals 0. So this matches up with this, provided a is 1, giving you the x squared. B has to be negative 5, so that if you substitute negative 5 for b here, you will get a negative 5x. Okay? And c equals 6. So you get x equals negative b, which is negative of negative 5, plus or minus the square root of negative 5 squared minus 4 times 1 times 6 over 2 times 1, and that equals negative of negative 5 is 5. And then you're going to have plus or minus. Well, what's in here, and everybody simplified it correctly, what's in here simplifies down to 1. You get 25 minus 24. The one thing you got to be careful of is put parentheses around this thing that you're going to square, so you don't accidentally write a negative 5 squared, which is negative 25. Okay? It's a common error. You're squaring the whole negative 5, so you want to put parentheses around what's being squared. You get that? And that's plus or minus the square root of 1 over 2, which is 5 plus or minus 1 over 2. Now, 5 plus 1 over 2 is 3. 5 minus 1 over 2 is 2. And we write the solution set using set braces, and we put the solution in those braces. That's how we write a solution set to an equation. Okay? Now, what's this mean? Because that's the important thing. What's this mean for the graph of this function? Okay, so if we're going to graph f of x, well, where this equals 0, solution to the equation where this equals 0 tells us where y equals 0, right? So if x equals 2, y equals 0, what's that mean? It means that the point 2, 0 is on the graph. And similarly, the point 3, 0 is on the graph. Okay? Now, that's one characteristic we get from the quadratic equation. I'm kind of reviewing what we did last time with a different example. But, so, hopefully, if you weren't here last time, you checked out the videos which were posted. They were, actually, Megan, you don't know where the videos are posted. Email me at your earliest convenience, and I'll enlighten you. Okay? Those videos would have been posted under the pre-calculus page, pre-calculus assignment. So if you looked at that assignment, you would have seen the MCR videos are clearly labeled with MCR in the title. Okay? So I don't think I told you that before, so I can apologize for not telling you that. But I do expect if you miss class, you're going to review the videos and do the homework. Okay? So we know that the graph of this thing is, well, I'm telling you, the graph is a parabola. I explained in class, to my class yesterday, why it was a parabola. It's by transformations. If you transform the x squared function with a vertical stretch and a horizontal and vertical shifts, you can end up with a graph that has the same basic shape anywhere in the plane, opening up or down. And of course, Megan, you've done that, so you know that too. And it always ends up like this. Because if you translate, shift, and stretch the x squared function, you get an ax squared plus bx plus c function. Okay? Okay, well, in any case, you have, okay, since this is a parabola, well, it's symmetric. And nothing you can do, symmetric about a vertical line through the vertex. Nothing you can do by stretching, shift, or shifting it is going to change that. The vertex is still going to lie on the axis of symmetry, a vertical line that's the axis of symmetry. And since it's an axis of symmetry, it has to be halfway between the two zeros that you get here. Okay? So the axis of symmetry is halfway between the zeros. By symmetry. If it wasn't an axis of symmetry, if it isn't halfway between the two zeros, then these points are a reflection of each other through the axis, and it's not symmetric. Okay? And it has to be symmetric because it's a parabola. Because the x squared parabola is symmetric for very obvious reasons, and because of shifts and translations and stretches. Okay? It stays that way. Okay, so the axis of symmetry is at x equals 2 plus 3 over 2 equals 5/2 or 2.5, which is clearly halfway between 2 and 3, and you know that. Okay, so you didn't really have to do this arithmetic to tell me 2.5 is halfway between 2 and 3, but I wanted to demonstrate the arithmetic because sometimes it's not so obvious. You know, you gotta have the numbers in front of it. Okay, so there we have that. Now, you also get the axis of symmetry from the quadratic formula. Where do you see the axis of symmetry in this expression right here? Well, you see 5/2 right there, right? Of course, it's plus or minus 1/2 because of the 1, right? But this part of it, 5/2 matches this. And also, where does it come from? Well, that's your negative b over 2a. So there's your axis of symmetry. Now you have to know the formula for the quadratic, you have to know the quadratic formula. If you want to memorize a separate formula for the axis of symmetry, you can, but it's sitting there smiling at you within the quadratic formula, right? Okay? So once you have the quadratic formula, you just got to know what to look at and reason out. Okay? And this has to be halfway between the two zeros because b plus this square root and b minus this square root have b right in the middle. You might think about that, but there it is, okay? So anytime you have a quadratic function in this form and want to talk about the graph of it, you want to immediately go to the quadratic formula and extract the information that you get from the quadratic formula, okay? Which is the location of the zeros, or maybe there aren't zeros and you get that information. Even if there aren't zeros, though, you have the axis of symmetry. I mean, there won't be zeros if this thing under the radical is negative. You can't take the square root of a negative, right? And we're going to do an example of that. So okay. Well, what can we do next? Well, the vertex lies on the axis of symmetry. So it occurs for x equals 5/2. Corresponding y coordinate is f of 5/2. You plug 5/2 into this, and that gives you the y coordinate, because that's what y is equal to, right? So y equals f of 5/2, which equals 5/2 squared minus 5 times 5/2 plus 6. Okay? And I believe that's 25/4 minus 25/2 plus 6. Negative 1/4. Now that's just like what you saw in class last time, if you were here, or on the videos. Just on the videos. Okay? So, vertex is at 5/2. Negative 1/4. So, purple circle around that and make a purple X here. Okay, so that's -5/2 negative 1/4. And if this is negative 1/4, then negative 1 would be about here. Negative 2 would be about here. 1, 2, 3, 4, 5, 6, 7, 8, maybe there. Okay? Now what's the Y-intercept? Well, the last thing is the Y-intercept occurs when x equals 0. Okay? At this point, y equals f of f of 0 equals 0 squared minus 5 times 0 plus 6 equals 6. Okay? So 0, 1, 2, 3, 4, 5, 6. So the point is 0, 6, and there it is. Now, you can draw a pretty good approximation to the parabola. Going to go through this point, it's going to go through these points, it's going to look like the y equals x squared graph, stretched or compressed or whatever, but it's going to look something like this. Okay? So from the quadratic formula, you get this much information and the axis of symmetry. You get the vertex, and then you can easily find the Y-intercept. Gives you enough information to sketch a good graph. Okay? So what I'd like you to do is do everything I just did with a different function. make it x squared minus x plus 6.